Hello, I am Dinisharan from Group 9 ODE assignment. So today I am going to explain about the question 1. So this is the manual calculation for the question 1. Okay, this is I use MATLAB for simulation. So let's see the question 1 MATLAB. Okay, this is the question 1. Given an expression y equal ax square plus bx, obtain an ordinary equation from this expression by eliminating the constant. So at here I use this code to obtain the result here. So as we can see, this is the question, this is the equation 1, equation 2. So the q is represented as the y prime and the w is represented as y double prime, because in this MATLAB I can't put the y prime because it's read as a different value. It never read as an unknown, so it read as a different value. So I put q as a y prime and w as a y double prime. So this is the final result I get from eliminating constants. So y equals y prime x minus y double prime x square over 2. Okay, let's go for question 2. Okay, this is the question B. So this is the manual calculation. Okay, this is the simulation. So the question B show that y equal x cube over 2 plus c over x is the solution of the differential equation dy dx equal to x square minus y over x. So at here I use this code. This is for showing this image, and here ODE different is for the differentiations. So you will get the y value. So as a f print s to rotate at proof. So this is the output here. So the answer is y equals c over x plus x cube over 2. So it's a proved that this is the solution for the differential equation. So let's go for question 3. Okay, this is the proved in MATLAB. Okay, this is question 3 where we have to do in separation method and power series. So the answer I obtained in separation method is y equals ce negative x cube over 3, and same goes to separation method. A0 is a c add in the separation method. In power series is a0, so a0 exponent negative x cube over 3. This is the, let's go to MATLAB. Okay, this is the question 1c. Okay, this is the method of separation variable and power series. Okay, and here I use the code. So the dsolve ODE is for solving this ODE. Okay, the answer I obtained in the MATLAB is C1 exponent negative x3 over 3. So as the conclusion, I want to tell, by the simulation and the manual method, the answer is the same. So that's all from me. Thank you.
Good morning, doctor. My name is Darshini, daughter of Anbalagan. My matrix number is CE210130, and I will be presenting question 2A. And question 2A is determine the solution of y double prime minus y prime equals to exponent 2x minus x plus sine x using the method of undetermined coefficient. So I use undetermined coefficient method to calculate this question. So my YC is equals to a plus b exponent x and my YP2, my YP1 is CE2x minus dx square plus by EX. And my YP2 is F cos x plus G sine x. And my YP prime 1 is equals to 2 CE2x minus 2 dx plus E. And my Y double prime P2 is negative F cos x minus G sine x. And my YP2 prime is negative F sine x plus G cos x. And my Y prime double prime P1 is equals to 4 CE2x minus 2D. So I have substitute all of my YPs into the equation, and I got 4 C equals to 1 over 2, D equals to negative 1 over 2, and E equals to 1. And G equals to negative 1 over 2, and F equals to 1 over 2. And my final, and I have subtracted all of the YP. So my final YP is equals to exponent 2x over 2 minus x square over 2 plus by x plus by 1 plus by 1 over x cos x minus 1 over 2 sine x. And my final output is y equals to yc plus yp, y equals to a plus b exponent x plus by exponent 2x over 2 minus x square over 2 plus x plus by 1 over 2 cos x minus 1 over 2 sine x. So I have used MATLAB to simulate my question A. So this is my question A. So I define M for the equation. So I use S equals to solve equation method to obtain the value of M and for M. So the value of M is 0 and 1. And I've also defined A, B, X, and A to rewrite the equation. And we couldn't use the same alphabet repeatedly twice or thrice. It's because MATLAB, it wouldn't accept it. So I use A as YC. So this is the equation. Then I define YX. I define YX to bring the answer. So I have dy means d prime y prime, and d2y means y double prime. So in this equation, I differentiate dy and d double prime. So these are the final answer I have get. So this is my question 2b. Question 2b shows that using variation parameter method will produce the same solution as question 2a. So with the same question, I have used variation parameter method to calculate this previous question. So same, I calculated M as 0 and 1, and my YC is A plus B exponent X, and I have calculated W. You have to use matrix method to calculate W. So my value of W is E exponent X. And I have to calculate U. So the formula for U is negative integrate y2 fx times fx over a w dx plus by a. So my final value for U is negative exponent 2x divided by 2 plus by x square over 2 plus by cos x plus a. So my final, my V value, so to calculate V, and this is the formula, so integrate y1 fx over a w dx plus by b, and my final value for V is exponent x plus 1 over exponent x minus sine x plus cos x over 2 exponent x plus by b. So the final step to calculate the value is y equals to u y1 plus v y2. So my u is negative exponent 2x over 2 plus exponent x square over 2 plus cos x plus a times by 1 plus by, and my v is exponent x plus 1 over exponent x minus by sine x plus cos x over 2 exponent x plus b, and my y2 is exponent x. So my final value for y is a plus b exponent x plus e 2x over 2 plus x square over 2 plus x minus by sine x over 2 plus cos x over 2. So for question 3, I have used MATLAB also to calculate the outcome. So this is my question 2B. So as I said previously, I've defined M to calculate the value of M. So I have obtained 0 and 1. So to show the equation, to show the YC, as I said, I couldn't repeat same letter twice or thrice because MATLAB wouldn't accept it. So I define A as YC, and my A is B plus A exponent X. And then I differentiate once I I define A1 as YC1, that is EX, and A2 as YC2 as 0, and these are the matrix method that I've used to calculate the value of W. As I said, the value of W is exponent X. So exponent X. And these are the value for U. These are the value for U. And these are the value for V. And these are the final answer. As you see earlier, my final answer for question 2A and my final answer for question 2B is the same. Hence, proved that whether I use undetermined coefficient or variation parameter, I will still get the same answer. That's all from me. Thank you.
Hello, good morning. My name is Sailesh Raki Gopal Krishna, metric number CE210068 from Group 9. So today I would like to present our assignment. So I will be presenting the question part 3. So as you can see at this question part 3, given a non-homogeneous system of first order linear differential equation as shown below, so we have to evaluate the general equation for the homogeneous system, determine the particular integral, formulate the general solution, and finally calculate the particular solution. So in order to solve this system of first order linear differential equation, there are these 4 main steps in solving this differential equation. So I will show you my manual calculation. Okay, so firstly we have to convert this both differential equation into matrix form as shown here. So after converting into the matrix form, we have to find the eigenvalue and eigenvector, and then after getting the value of the eigenvector and eigenvalue, third step would be for we have to find whether this equation is linearly independent or not. So based on this my calculation, this equation is an linearly independent equation. Then the next step will be by obtaining the general equation for YC, and then for step 5, which is part B for the question, we have to determine the particular integral for the non-homogeneous system. So by referring the YP table, using this G value, we can say that this is the case 1 equation, and then we have to sub this U1 and U2 into the equation of YP. So this is the calculation for the substituting method, and the step 8 will be equating the coefficient into the value of the U1 and V1 U2 and V1 U2, and we have to compare the value of X, and then we have to sub this U2 into the second equation, and before that we have to sub the second equation into the first equation, and then we have to compare again, and finally the value of YP based on my calculation is 0.5 and 0, and the ninth step, which is part C, will be obtaining the general equation. So we have to find the YC and YP and then add them together, and finally the last step, which is the part D, by applying the initial condition when y equals to 0, x is 1 and negative 1, and based on the calculation and the substituting method, we are able to get the value of y1 and y2. So next I will show my MATLAB calculation. Okay, so this is my MATLAB calculation. So firstly I have introduced the MATLAB of my symbols to the MATLAB, and I have defined the metric form. So the MATLAB has given the output in the matrix order, and I have substituted the value of G and given the value of Y, and then by equating the differentiation of Y, and then by initiating the value of C using the initial condition, we are able to get the final answer, which is the value of y1 and y2. So based on this final equation, if we expand this equation, we will able to get the same answer as the manual calculation, since MATLAB can expand this calculation. So that's all from me. Thank you.
Hi, myself Madan Raj Balachandran, and I'm going to present you about the question 4 for the assignment of ordinary differential equation. So for the question 4, A is the given in a differential equation, which is y double prime negative minus 8y prime plus 3y equals to ft. So the question is find the piecewise function of ft. So this is the manual calculation for the question 4A1, and moving on to question 4A2 is to find the Laplace transform ys of the differential equation with initial values. So this is the manual calculations for the question following, and here is the answer of the question. Ys equals to, moving on to question 4B2, B1 equals a series RL circuit is shown in figure Q4. So the question 4B1 is, by applying Kirchhoff law, show that the circuit can be represented by the following equation: dit over dt plus 5i t equals exponent negative t bracket t minus 1 and h bracket t minus 1. So here is the calculations for the question B1, and moving on to question B2 is to determine the current IT for the circuit using Laplace transform with initial condition of I equals to 0. So this is the manual calculations for the question. And these are the calculation in MATLAB application. Thank you.